Video for the Chapter 9 test. If you, like I told you, if you got on here and redo the test, I'd give you some extra points added to your test. So hopefully you're watching this video. The first one, describe the tessellation. Remember, if we have a tessellation that looks like this one, it's got all regular polygons in it, so we know it's regular. And we look at each vertex, and if they all come together exactly the same, then it's also uniform. And the answer to this one is A, it's uniform and regular. What type of dilation occurs with a scale factor of 1? It's not an enlargement, it's not a reduction, and we didn't talk about congruent or inverse transformation. The answer here is C. Next one, which of these shows a translation? Remember, a translation is a slide. So which one shows a slide? Well, this one looks like it's rotating it. This one looks like it's rotating it. This one here got smaller or bigger, whichever way you're looking at it. So the answer here is C. Name the image of C, 6, -4 under rotation 90 degrees, counterclockwise about the origin. Well, the rule for 90 degrees counterclockwise, remember we have a rule, it's like X, Y goes to whatever it goes to, and if you go back to your notes, we're dealing with rotations here. So I'm going to pull up this set of notes. Counterclockwise rotation 90 degrees. XY goes to -YX, so it switches them and takes the opposite of the new first coordinate. So it goes to -YX. Well, we'll just take this then and we do that to it. We switch them and take the opposite of the first one, so it's going to end up being the -4 moves to the first, but then we change it to positive, and 6 moves to the second, so 4, 6, which is A. Again, I know I'm going pretty quickly through these, but I don't want to spend a whole lot of time. I don't want to make this video real long, so name the image under the translation. X plus 1, Y plus 7. That means you're going to add 1 to the X coordinate. So -11 plus 1 is going to give us -10, and you're going to add 7 to the Y coordinate. Well, -6 plus 7 is going to be 1, so -10, 1, which is C. Number 6. Number 6 says Reba wants to enlarge a 3x4 picture, so she's got this picture and it's 3x4. She wants to make it bigger. Well, all you do with that is you take the scale factor and you multiply it by both the length and the width. 2.5 times 3 is 7.5, and 2.5 times 4 is 10, so the new dimension is going to be 7 by 10. So the answer is B. Number 7, if A prime, B prime, C prime is the image of A, B, C under a dilation with center at 0, 0, find the scale factor. The easiest way to do this, if we go here and we find the coordinates of A, that's 0, 3. We go in here and find the coordinates of A prime, which is 0, 1. Well, A is bigger than that A prime was, so we know it's a reduction. So if it's a reduction, it's got to be a fraction as the scale factor. And we can just compare these. So 1 to 3, which won't reduce. So the scale factor is 1/3, which is C. Remember, it shouldn't be a negative because then it would like flop around. Given that 3, -7 under reflection, so we want to know what reflection we're dealing with, and it looks like all that happened here is the rule was XY went to, they stayed in the same order, so it still stayed at XY, but they took the opposite of the Y coordinate. So XY went to X -Y, Well, if we go back to our notes for reflections, which is this set of notes, if you look back at them, and we look through all the rules there, I don't see one on that one. Let's look at this one. AB goes to A, negative B. That looks like the one, so it looks like we reflected over the x-axis. So reflect over the x-axis is A. Second page, find the sum of the measures of the angles of a polygon in a tessellation at a vertex. So all that's saying is each one, wherever you pick a vertex, what's the sum of all the angles? Well, any tessellation you're looking at, you have so many vertices that come together right there at that one point. Well, the sum of them is always going to be 360 because it's always that full circle. The next one, if you're watching this video and you bring your test back in and I marked this wrong, I'll probably give you a point added right back directly to your test because I think I took the answer out of the book and I shouldn't have done that. We're looking at this and it looks like to me that all the shapes are regular shapes. And if we look at each vertex, well, they're a little different. They're not coming together the same, so it should probably not be uniform. So it should be regular, but not uniform, or not uniform, but regular. So the answer should probably be C. But if you put A, I would have accepted that also maybe, because you could consider that uniform maybe. It's probably not supposed to be, but I would accept it. What type of dilation occurs with a scale factor of 1/4? Well, if it's got a scale factor of 1/4, that means it's getting smaller, so it's a reduction. B, which translation moves every point? In the pre-image, 4 units left, 4 units to the left is your X. So if you're going 4 units to the left on the X, that means you're going down, so you're subtracting 4. 6 units up is your Y, so that means you're going up 6 units or adding 6. So we want X minus 4 and Y plus 6, which is B. Problem 13. Find the magnitude of the rotational symmetry in a square. We have a square. The order of rotational symmetry, remember you put a dot right in the middle. The order is just how many times it's going to look exactly the same as you rotate it around one whole circle or 360 degrees. Well, a square is going to look the same 4 times, so the order is going to be 4. Then we take that whole turn, 360, divide it by 4, which gives us 90. So the answer is B. Find the image -7, 4 for a dilation centered at the origin with a scale factor of -3. All you do with scale factor is you take that and you times it, take the scale factor times each of the X and Y. So here -3 times -7 is going to give us positive 21. -3 times 4 is going to give us a -12, which is B right there. Number 15, LMNO is a trapezoid and it gives you all these coordinates on here. Find the coordinates of the image in under the translation. So all we really care about is the in right here. They didn't ask us to find all the rest of them. And all we're going to do is subtract 7 from the X and add 9 to the Y. So we're going to take 5, that's the X coordinate, minus 7, which gives us a -2. 5 minus 7 is -2. Add 9 to the Y, -3 plus 9 is positive 6. So the answer should be -2, positive 6, which is A. Number 16, what type of dilation occurs with a scale factor of 3/2? Well, you gotta be careful on this one because it is a fraction, but it's top heavy. So it's actually an enlargement. So A. Number 17, find the scale factor of triangle D prime, E prime, F prime, or if triangle D prime, E prime, F prime is the image of triangle DEF under dilation with center at C. Well, the two look like they're exactly the same size, so we know the scale factor is 1, but the pre-image looks like it jumps over the center point, which is right here. And if that's the case, then we know that it has to be a -1. So the answer is C. Anytime you have a negative scale factor, remember it jumps over the center point. If you have a positive scale factor, it stays on the same side. Number 18, Sue scans a picture, a 4-inch picture into her computer. She stretches it to 10 inches. So if it started at 4 and it went to 10, we know it got bigger. So it's an enlargement. Well, if it's an enlargement, then the scale factor has to be bigger than 1. So when we go to set up our fraction to find the scale factor, we want the bigger number on top and the smaller number on bottom. And we reduce that. 5/2, so the scale factor is 5/2, which is B. Given that C is 2,9, under which reflection is C prime going to be 9,2? Well, it looks like all they did, the rule was XY went to, and all they did was switch the X and the Y, so went to Y, X, and we need to figure out what rule that is. And if we go back to our things here for reflections, that's this video, we just want the two to switch. I don't see any of those rules that look like they switch. Let's go to this one. Looks like reflect over Y equals X just turns the two around. So that's the one that we want. So it goes over the line Y equals X. So that would be D. The third page is where we had to start actually working the problems out. The first one says draw the lines of symmetry. Remember, a line of symmetry is a line that takes the shape, cuts it into exactly two parts that are perfectly equal, and it's also got to be able to fold over that line, and then the sides have to match up. So that's one line of symmetry. My lines might not be perfectly straight. That's 2, 3, 4, 5. That's what you should have drawn on that one. Graph triangle TUV with vertices 3, 3, 6, -1, and -2, 1. Looks like we need some extra. It's got 6 units here on that X for that U. So I'm going to draw my Y over this way a little bit maybe, because we need more X's. So maybe put my X axis there and my Y axis there. Now when I go to graph it, 3, 3 over 3 up 3. That's T. 6, -1. 1, 2, 3, 4, 5, 6, -1. That's U. And -2, 1. That's B. Connect them. That's our pre-image. We want the image of TUV reflected over the line Y equals 2. Change my color here again. The line Y equals 2, remember, anytime you have Y equals 2, you go to where Y is 2, and it's a horizontal line. So we go up to where Y is 2, and we're actually going to reflect it. I could draw it straight across that line. Now the easiest way to do it is just to count. So V started here. Change my color again. V started there, and it's one space below our line, so we want it to be one space up. That's going to be V prime. T was one space above the line, so it's gonna be one space below, that's gonna be T prime. U was 1, 2, 3 spaces below it, so it's gonna be 1, 2, 3 spaces up. That's U prime. We connect those. And our image should look something like that. (22) Determine whether P prime, Q prime, R prime is a translation. Another name for a translation is a slide. So we're trying to decide whether it's a slide or not. And they want you to explain your answer. Well, we look at this, and it looks like one of them's bigger than the other, so it can't just be a translation. So the answer should have been no, and the easiest thing to write is it got bigger. That's the easiest way. Just got bigger, so it was a dilation. Write the coordinates of the image of -2, 5 reflected in the y equals x. I think we just did that one a minute ago. If we go back to our notes here, y equals x, it just switches the coordinates right there in our notes. So if we go back here, y equals x, all we should have to do is switch the coordinates. So the new coordinates should be 5, -2. All right, 24, graph the vertices, and they give us those vertices. Then graph the image reflected over the y-axis. I'm drawing the x-axis and the y-axis. Actually, I drew the y first, but that shouldn't matter. So something like that. This is our x, this is our y. Graph the points. 1, 2, 3, 4, 4. That's A. 3, -2. My pen's a little off. That's B. -1, -1. That's C. So that's our original shape, our pre-image. We want to reflect it over the y-axis. Well, this is our y-axis here. So that's the line we're reflecting across. And the easiest way is just to count. C was one space to the left, so now it's going to be one space to the right. That's going to be C prime. B was 2 or 3 spaces to the right. Now it's going to be 3 spaces to the left. So that's B prime. A was 1, 2, 3, 4 spaces to the right. Now it's going to be 1, 2, 3, 4 spaces to the left. That's A prime. Connect those. And our image should look something like that. Next one, how many lines of symmetry does this figure have? Well, that would be a line of symmetry because it folds exactly, or cuts it into exactly 2 equal parts, and they fold together perfect, and that's the only one. So there's only one line of symmetry for that. Find the measure of the image of segment GH. If segment GH is 7 units long with a scale factor of 5, all you got to do there, 7 times the scale factor, and that's going to give you your answer. So G prime H prime would be 35. (27) We want a scale factor of 1/3. Well, 1/3, it's positive, so it should be getting closer to the center point, which is G, and it's a fraction, it's 1/3, so it should be getting smaller. And all I'm going to do, we want about 1/3 of that distance from there to there. So I'm going to say somewhere about in there, that's going to be C prime. 1/3 of this distance up here, about there maybe. And this one over here, about 1/3 of that, somewhere about in there. And I'm going to change my pen color again. Star shape, oops, I missed my point. It's going to look something about like that. And my pen's awful thick, so I got a little bigger than it should have been. Somewhere about in there maybe. Problem 28, describe the tessellation as uniform, not uniform, regular, or semi-regular. First thing, the easiest thing is regular or semi-regular. None of these shapes They're all rectangles, so none of them are regular, so it's not regular, and it's not semi-regular, so it's neither one of those. As far as the uniform goes, if we check out all the vertices, that one has 3 rectangles that come together there. That one has 3 rectangles that meet there. That one has 3. So it's uniform, but it's not regular. And if you just wrote uniform, I accepted that. If segment AB is 10, segment A prime, B prime is 5. Well, if we go from here to there, this is our pre-image, this is our image, then it got smaller, so we know that it is a reduction. Complete this statement. The image -3, -5 under what rule goes to 6, -1? Well, it doesn't look like it's a reflection or a rotation, so I'm guessing it's a translation, which is a slide. So all we're going to fit in there is we're going to figure out how much did we move the x and how much did we move the y. Well, if you go from -3 to 6, move the x to the right 9 units. And if we go from -5 to -1, we move the y up 4 units. So that would be our answer. X plus 9, comma, y plus 4. Next one, draw the, move this up. Probably better erase some of that, can't see it. Draw the image of PQR with, and they give us the coordinates reflected over y equals 1. Looking at this, that 2, 8, so the y, we need quite a bit of y. So I'm going to drop my x-axis way down here. We need some, we don't really need any special x's, so just put the y right here. And let's graph those 0, 4, 0, 1, 2, 3, 4. That's P. 2, 8, 2, 2, 4, 6, 8. That's Q. And -3, 1, 2, 3, 2, 3, 4, 5, 6. That's R. Connect those. Alright, that's our pre-image. They want us to reflect it over y, or I'm sorry, x equals 1. Anytime you reflect something over x equals 1, remember that's going to be a vertical line. So we go to where x is 1, and we draw in a vertical line. We go right through there. That's what we're reflecting across. The easiest way, again, is just to count. P was 1 space to the left, so it's going to be 1 space. P prime is going to be 1 space to the right. R was 1, 2, 3, 4 spaces from the blue line, so it's going to be over this way, 1, 2, 3, 4, somewhere down there if I could hit it. That's R prime. Q was 1 space to the right of the blue line, so it's going to be 1 space to the left. It's going to be Q prime, our new shape. It's going to look something like that. 32, write the coordinates of the image S, -1 or -7, 1 reflected in the y-axis. So again, if we go back to our notes, reflecting over the y-axis, that's not the one we want. Over the y-axis is right here. Looks like the coordinates stay in the same order, but you change the positive, or you do the opposite of the first coordinate, the x-coordinate. So we're taking this, and all we're going to do is take the opposite of this first one, which is going to make it 7. The second one stays the same, so our answer there is 7, 1. Problem 35, draw the image of triangle PQR under rotation 45 degrees clockwise about point T. Change my pen color here. So let's use one of these dotted ones. we're gonna go 45 degrees clockwise, which is gonna be around this direction. Let's see, let me change it back. So we wanna connect that to T, and we wanna go 45 degrees around this way, so maybe something about like that. That looks maybe about 45 degrees. Again, it didn't have to be exact. Then we sort of measure our new R prime is going to be right there. Do the same thing. This isn't going to look very good with me not being able to erase all this. About 45 degrees, somewhere out in there maybe. Measure it. So Q prime is going to be somewhere about in there. Connect it to P, 45 degrees. Measure how far out we are, somewhere about in there. That's going to be P prime. Change colors again, make it red. So if I connect those three, might have made my shape a little stretched out, but should be something about like that. So we turned it around that way, we turned it this way, and it looks about the same. Mine might have gotten a little big. Maybe it should have been up there. My pen's not perfect. But that's about what it should look like. Draw the image of MNO, triangle MNO under dilation with center C, scale factor 2. Well, the scale factor is positive, so that means it's going to stay on the same side of C, the same side. So it should go out up in here somewhere. Should be on this side. And it's got a scale factor of 2, so that means it's going to get bigger. So all I'm going to do on this, draw a rays right through there, right through there, right through there. And then you sort of measure. Change my pen color again. Back to blue. Measure, we want 2 times, so we measure out twice. And our M prime is going to be somewhere right there. N prime will be somewhere about in there. O prime, somewhere about in here. Connect those. And that's what our new shape should look like. Made it 2 times bigger. It went out on the same side of C. And the shape looks about the same. 35, identify the order of magnitude of rotational symmetry in a regular 20-gon. Well, if I could draw a regular 20-gon, which I can't, you know it has 20 sides and they're all the same, so as we spin it around in one whole circle, the order is how many times it looks exactly the same as it did when we started. Well, the order is just going to be 20. So that's one of our answers. Order is 20. And then to find the magnitude, all we do is take 360 divided by 20. Zeros cancel out. If you're dividing there, 2 will go into 36. 18 times, remember that's a degree. So the magnitude is 18 degrees. And what that means is each time you turn it, so it looks exactly the same, it moves 18 degrees. Next page, 36, when a figure can be folded so that the 2 halves match exactly, the fold is called a line of symmetry. It's a line of symmetry. Yeah, my R and my Y sort of went together there, but it's a line of symmetry. A blank is a transformation that requires a center point and a scale factor. Anytime you have a scale factor, then you have an enlargement or a reduction, which is called a dilation. triangle XYZ has vertices, and they give us the coordinates there. Find the coordinates of the image after a dilation centered at the origin with a scale factor of 4. Your scale factor is 4. All you got to do to find the new ones, and I'm going to write them here in this space instead of trying to write them on the blanks because I don't have enough space over there. So to find x prime, all you do is you take the 4 times the x and y coordinate there. So it'd be -4, 12, that's your x prime. Y prime, you do the same thing, is multiply both the x and the y by 4. 4 times 5 is 20. 4 times 7 is 28. Then z prime, multiply both those by 4. So 4 times 2 is 8. 4 times -4 is -16. Those are your new coordinates. Find the image of segment CD with the coordinates under rotation 90 degrees counterclockwise about the origin. Again, I'm going to go back to our notes here and find out what 90 degrees, a rotation 90 degrees counterclockwise is. The rule for 90 degrees counterclockwise is xy goes to -yx. It switches the coordinates and takes the opposite of the new first coordinate. So -yx, and that's all you're going to do to these. Again, I don't have room to write out there on the line, so I'm going to write it right here. C prime, you switch the two and take the opposite of the new first one, so -4, 0. D prime, you switch the two and take the opposite of the first one, which would be -4, 3. Find the image of WX with, and they give us coordinates under a translation, which is just a slide, of x -4, y -3. So W prime, you're just going to subtract 4 from the x coordinate and subtract 3 from the y coordinate. So W prime is going to be 7 -4, which is 3, and then 1 -3, which is -2. And x prime, take the x coordinate, which is -4, and you subtract 4, so you get -8. Take the y coordinate and you subtract 3, so 5 -3 is 2. Those are our two answers. All right, on the bonus, I'm going to go through these sort of quickly. The first one, I don't really expect that you could have completely figured it out, but if you tried to figure it out and you had point D up here, which was 0,6, and you rotated it 30 degrees clockwise, which would end up putting it somewhere over in here, and you actually found that coordinate, I would give it, I gave you credit. Later on in the year, we're going to learn this, that we could complete this right here, and it would be a triangle, and one of those angles is a 30 degrees, 30-degree angle, then another one is a 90-degree angle, and we're going to learn some stuff about a 30, 60, 90 triangle. So if you just gave me some answer that was sort of close, I gave you credit for that. I don't expect you to know that yet, but know that's something that we will learn later on in the year. The next one, scale factor. Scale factor of 1/2, and then you're going to reflect it over the x-axis, so we're doing a composition. Remember, a composition is when you do two things, or two or more things, to one shape. So we're doing a composition here. Well, our first thing is we're going to find E prime, and that's all you do is multiply everything by 1/2, so you get 1/2 times 4 is 2, 1/2 times -1 is -1/2. F prime is, take 1/2 times both those, so that'd be -1 and -1.5. D prime, which I missed, should have done it first. It's up here. Take half of that, and that's 1/2. And half of 3 is 1.5. So that's our first thing, that's our using our scale factor, our dilation. Then we want to do a reflection over the x-axis. Well, if we go back to our PowerPoints and look at reflections, and we just want over the x-axis, we see that AB goes to A, negative B, so all you do is change the sign of all the y coordinates. So we can go back here, and I'm actually gonna write it right here. So we take this and we change the sign of all the y coordinates, so we get 1/2, negative 1.5. You just change the sign of that one. E double prime, change the sign of this one, so it's going to be 2, 1/2, and F double prime, change the sign of that one, so it's going to be negative 1, positive 1.5. Those are the coordinates that they were looking for after we do the composition. This would be right if I messed up right here. That should be 1. D prime, that should be 1 right there. Half of 2 is 1, not 1/2. So that should be 1 right there. Get in a hurry and not pay attention to what I'm doing. Number 3, given B is that under which reflection is B end up being that, will it just change both the signs? And the answer was, the rule for going over the origin is XY goes to negative X, negative Y, just switches the sign of both of them. So the answer to that one was just C. Number 4, got a square, and we're going to reflect it over X equals 1, and then over the Y axis. If you grab you could have grabbed a piece of graph paper or something if that would have helped you to do this. Remember, if you're going over X equals 1, that's your X and Y axes. You go out to where X is 1, so you're reflecting it over that line right there. And I'm not going to completely do this one all the way through because I want to get this video finished. But all you do is you draw in your square, so you go to 1, 1, out 1, up 1, 1, 6, out 1, up 6, and 6, 6, so out 6, up 6. And this is something sort of close, it ain't exactly out 6, up 1. So our square somewhere starts off somewhere like that. And if we go over the x-axis, or I'm sorry, not over the x-axis, over this line right here, x equals 1. Well, these 2 points are going to stay exactly where they are, and these 2 are going to be out 5 spaces from that. No, yeah, out 5 spaces, so it should be back this way, 5 spaces. And your new shape would look something like that, and then you wanted to reflect that over the y-axis, which is right here. So then you're going to take it, and it's going to end up, if I change my color here, it's going to end up something like that, and you can find those coordinates that you'd have, just graph it out and stuff. The last one, you have to remember that scale factor, first of all, if it's 2, that means it's getting bigger. If it's a negative, then that means it's jumping to the opposite side of C. So what I'm going to do here is just connect S to C and go on through it. So it's going to be out here somewhere. Then we draw this ray out that way somewhere. Draw this ray out here somewhere. And what we want to do is find the distance from Q to C, and then we want our scale factor, which is 2, we want twice that. So we measure on the other side twice that space. Trying to get something to sort of measure with. Maybe somewhere about in there. That's Q prime. Measure from S to C. And go out 2 of those links. So something about there. That's S prime. Measure from R to C. Go somewhere about in there. That's R prime. Connect those. Our new shape should look something like that blue one right there. Looks like it's about twice the size. We jumped over C, so that's where the negative came into play. And it looks about the same. It's about the same shape. So if you copy these down, turn in that test, I'll give you some extra points.